Hello everyone. Today in this lecture we are going to learn how to design helical gear. So first I will read the problem. A helical pinion having 14 teeth which are made up of alloy steel 40 Ni2 Chromi 1 Moly 28. Ultimate strength of this material is 800 Newton per m square. Is to mesh with gear which is made up of carbon steel 55C8. Ultimate tensile strength for 55C8 is 720 Newton per m square. The gear pair is required to transmit power of 30 kilowatt. Pinion speed is 720 rpm, gear speed is at 220 rpm, load factor is 1.1, application factor is 1.3, number of teeth on pinion 1.4, face width equal to 10 module, tooth system is equal to 20 degree full depth, psi equal to 25 degree, load concentration factor, actually this term is not given, don't consider this load concentration factor. Factor of safety equal to 2, velocity factor equal to 5.6 divided by 5.6 plus under root v. We need to calculate module and the main dimensions of a gear pair. First we'll write given data as per the statement. So here power we need to transmit 30 kilowatt, pinion speed 720, gear speed 225 rpm, CL load factor 1.1, CA application factor equal to 1.3, number of teeth on pinion ZP equal to 14, face width B equal to 10 module, tooth system 20 degree full depth, helix angle psi equal to 25 degree, don't consider load concentration factor, factor of safety that is Fs equal to 2, velocity factor that is Cv equal to 5.6 divided by 5.6 plus under root v. As per statement of the problem, we need to find out module, that is normal module and transform module, and gear pair dimensions. So we'll solve it by step. Pinion is a weaker or gear is a weaker, that is the we need to decide. We can decide it by this product sigma bp into yp, sigma bz into yz. Sigma bp and sigma bz are bending strength of pinion and gear respectively. Yp and yz are Lewis factor of pinion and gear respectively. We can calculate bending strength for pinion and gear by using this thumb rule SUT by 3, SUT of pinion divided by 3, SUT of gear divided by 3. Lewis factor we can select from the chart or we can calculate by using formula 0.484 minus 2.87 divided by Z dash. Here Z dash is important. This Z dash means virtual number of teeth of a spur gear instead of helical gear, and formula for this to calculate Z dash or ZP dash and ZG dash, ZP dash equal to ZP divided by cos cube psi, or ZG dash equal to ZG divided by cos cube psi. Once we calculate the value of yp and yz, then calculate this product. So finally we got the value of 88.37, and for this gear product 10.76. Here use notation sigma bz. This is for the actually gear and this is for the pinion. So if we compare this value, product of pinion is smaller, so we can say pinion is weaker. So further design will be on the basis of pinion. Step second, pinion is weaker, so it is necessary to design on the basis of pinion. But another important term is that we need to decide whether we are going for the beam strength calculations or wear strength calculation. But in this case, value of BHN is not given, so we can't go for the wear strength base. So we'll design on the basis of beam strength. If value of BHN is given, then we must go for the wear strength also. Now we will design by the beam strength base. Formula to calculate the beam strength is SB equal to MB sigma B YP. Here instead of Y we have taken YP because pinion is weaker. Sigma B is bending strength of pinion, that is SUT by 3. B equal to 10 into normal module, YP equal to 0.33. Just put the value of these 3, we'll get the value of SB, that is beam strength in terms of a module, normal module. Now step 3, to avoid beam failure, beam strength should be greater than the effective load. Effective load means that is total load acting on the gear. So SB should be, beam strength should be greater than the P effective. So SB equal to factor of safety into P effective. So to avoid failure, we introduce the factor of safety. But factor of P effective equal to CS by CV into PT. This method to calculate the P effective is known as a velocity approach method, because we are using the velocity factor. But CS is not given, that is service factor, so assume it 1. And V equal to, we need V to calculate the CV, V equal to pi dN divided by 16 to 1000. So in this way, if we put the value of dP equal to Mn into Zp, value of Np, then you will get the value of V in terms of Mn. Now formula for the CV is given, just put the value of V, will get the value of CV in terms of Mn. And general formula to calculate the power is a force by velocity. Here Pt equal to, just interchanging the term, will get Pt equal to Kw by V. Kw means power, V is the pitch line velocity. So once again we will get value of Pt in terms of a module only. Now put the value of CS, CV, Pt. But here concentration factor, load factor is given, application factor is given. Whenever another factor is given, at that time we need to multiply to the CS. So 1.3, 1.1 and 1 is the CS into PT. So already we got the value of PT in terms of Mn, and value of CV is this one. So finally, by simplified the terms, we will get the P effective in terms of Mn. Now in this equation we know the value of SB, which is in terms of Mn. Put the value of SB from equation 2 and value of P effective from this equation. Just simplify the term. Finally we will get the equation in a cubic form. Mn cube equal to 166.77 plus 22.72 under root Mn. We can solve it by calculator, or if you are unable to solve by calculator, we need to select value of Mn on a trial error basis. Means we need to select value Mn equal to 2, put here Mn equal to 2, here also 2, check left hand side and right hand side, then put 2.5, 3, 3.5. So whenever you observe difference of a left side and right side is a less, then that will be the Mn value. So according to these calculations, we got Mn equal to 6.11. Then we need to select this value of Mn from the table. This table will be provided to you. There are the two series, choice 1 series and choice 2. Generally, if series is not given, choice is not given, we prefer choice 1 preferred only. So our value is 6 point something, so we can't select 6. We need to select further next value, that is 8, for the safety purpose. So our module value is 8 mm. Then in the last step we need to calculate the gear dimensions. So for this given problem, 20 degree full depth system is given. If not given, always assume 20 degree full depth system. Now Mn equal to 8 mm, M equal to, that is module equal to Mn divided by cos sine, that is transfer module. So here the value of transfer module, dp is the diametral pitch equal to M into Zp. M means transfer module, already we calculated. So in this way we will get diametral pitch of pinion. Similarly calculate diametral pitch of gear, dz equal to M into Zg. Formula for addendum equal to Mn, that is 8 mm, and center distance equal to dp plus dz by 2. Already we calculated value of dp and dz, just put in this equation, we'll get the value of center distance. Thank you.